In this paper, we explore synchronization methods for resolving state conflicts on remapped physical virtual interfaces. Using haptic retargeting, remapped interfaces enable a single physical interface to provide accurate haptic feedback for dynamic user interfaces in virtual reality. We identified 3 types of stateful controls to explore: switch, slider, and knob. Each of these control types can be set in one of multiple different states by the user. For example, the switch could be on or off, or the slider could be at 0% or 100%, or any position in between. With multiple virtual controls being mapped to a single physical control, there can be cases where the virtual and physical control states don't match. This is considered a state conflict. We explored 2 synchronization methods to resolve these state conflicts: automatic and manual. In the automatic method, the physical control state is corrected automatically using electromechanical controls, while in the manual method, the user must make the correction themselves. For the study, a physical interface was developed with motorized sliders and knobs. A custom switch was developed that can toggle itself on and off using a servo. For haptic retargeting and the state synchronization to take place, the system must know which virtual control the user wants to interact with. When a target control is identified, in this case using a head pointer based selection method, the system checks for a state conflict between it and the physical control it is closest to. Then the state conflict must be corrected before the haptic retargeting can begin. Our user study explored the effect of haptic retargeting and the synchronization method used. In each task, the user saw 3 of one type of control. They were required to set the controls to a given state to complete the task. The 3 controls were remapped to the center physical control on the physical interface. Results from the study showed that the manual method significantly increases task completion times, resulting in more work for the user. However, it does enable the effective remapping of interfaces where actuated controls are not available. We also compared an ideal aligned interface where every control is mapped one-to-one with corresponding physical controls against a remapped interface with automatic synchronization. Task completion times were significantly lower for the ideal aligned interface than for the remapped interface. The aligned interface was also more usable than the remapped interface, although the median score on the system usability scale was above 80 in both cases. These results suggest that more work is needed to increase the usability of remapped interfaces. However, they can effectively provide haptic feedback for user interfaces in virtual reality with a range of control types. While the automatic synchronization method performed better, both methods expand the possible applications of remapped interfaces, enabling the remapping of stateful controls even where automatically actuated controls are not available.